afternoon everyone, welcome to the channel. In today's video I want to show how we can train a convolutional neural network using L1 and L2 regularization. L1 and L2 regularization are used for minimizing the overfitting in deep learning. So let's get started, and in today's video I will not write the code from scratch because I have already made a video previously on CNN, and if you are interested you can check that out. So I am basically using the same code, so I'm just gonna briefly explain. So at first, as usual, we need to import our required libraries. So these are the libraries that we need. So let's run this cell. Okay, so our PyTorch version is this and .python version is this one. Then we need to define the device. So in case GPU is available, our code will run on GPU, otherwise it will run on CPU. So let's run this cell block. So we have GPU available, and for this tutorial I will use FashionMNIST dataset. In the video where I typed up all this code from scratch, I just use USPS dataset, a different dataset, but that was also a grayscale dataset, same as this one. This one is also grayscale. So let's load our FashionMNIST dataset. So it's now being downloaded. Let's wait for download to finish. Okay, so download is finished. So let's check the length of train and test dataset. So we have 60,000 samples in the train dataset and 10,000 samples in the test dataset. We can also check the shape of the sample. So 28 by 28 pixels images. Now let's check the classes. Okay, so we have 10 classes. These are all different types of dresses and shoes. So t-shirt, trouser, pullover dress, coat, shirt, sneaker, etc. Okay, now let's visualize a few samples from the training dataset. So we are randomly selecting 50 samples from the train dataset, and you can see we have this pullover, shirt, bag, coat, sneaker, ankle boot, trouser, etc. Similarly, we want to visualize few images from the test samples. The same types of images are also available in test dataset. Now it's time to define the data loaders. So this will actually convert both the train dataset and test dataset into an iterable, which we can use for training the CNN. Okay, so let's define the data loaders. Now let's also check the length of each data loader. So 1875 and 313. So 32 samples in each of them apart from the last one, because I don't think dividing 60,000 by 32 will give the remainder 0. So the last one will not have 32 images. Same for this one as well. Test data loader. Now it's time to define the network architecture. So this is how we can define a CNN. So let's run this cell, and now let's visualize the model architecture. So this is how this input is changed through all these layers. So it reduces to 14 by 14, then 7, 7, 4, 4. These are the number of channels. Then so this part is the feature extraction. F underscore is feature extraction part. After that we flatten and connect the output of feature extraction to a fully connected network which performs the image classification task. So this 10 is for the 10 classes that we have here. So these are the 10 classes. Okay, now we need to define the train batch. So in case of train we need to use optimizer to update the weights, but in case of test batch we do not need optimizer because the model do not learn anything from these samples. It just shows its performance after learning about the patterns of images in the train batch and performs on the test batch in each epoch. So let's run it, and this is the accuracy function. So we need accuracy for measuring the performance of the models to see how much it has correctly predicted the labels. So this is the accuracy function. Then after that we need to set up the model loss function and optimizer. So in image classification task normally cross entropy loss is used, and we are using Adam with learning rate 0.001 in this case. So now it's time to train the model. We will train for 10 epochs, and this part is for the train samples and this part is for test samples, and then we are printing the performance of the model. So let's run it. It will take a little bit of time. Okay, the training is finished. So let's plot model loss and accuracy. So this is our loss curve and accuracy curve, and if we look at this part, this is where the problem starts. So after decreasing till here, then gradually starts increasing. Only the train loss is decreasing. So this is the case of overfitting, where the train loss is gradually decreasing, but after some time test loss starts to increase. And this is kind of misleading. It's not fluctuating as much as it's showing because the scale is very small on the y-axis. We can see that it goes from 89 to just over 90. So the accuracy is not fluctuating that much, but the loss is increasing in case of test dataset, but in train case it is decreasing. So this is overfitting a little bit. Now let's check the model prediction. So this is our model. So we are randomly predicting the outcome of 9 samples from the test dataset. So in these 9 samples, one wrong prediction. So this is actually a shard, but the model predicted it as quote. So in case of wrong prediction, the label will be changed to red, and in case of correctly predicted labels, it will be blue. Okay, so this is how a normal CNN can be trained without any regularization. So I didn't type up this particular code because I have already made a previous video on CNN, and I will give the link in the description if you want to see how the code is written from scratch. Then you can look at this video. So now it's time to train the CNN using L1 and L2 regularization. So let's copy few things. So let's just copy this part. So previously 13, so this will be 14. So define the train batch with L1 regularization. Okay, also copy this part as well. Here we need to make few modifications. So let's add the L1 regularization part. Okay, so let's alpha 0.001. This is a hyperparameter. L1 norm so this will be some param for param in model dot parameters. So L1 regularization is also known as L1 norm. Now after calculating L1 norm, we need to add it to our cross entropy loss. So we have alpha L1 norm. So this is the additional part we need to mention for training a CNN with L1 regularization. So this alpha is hyperparameter. We can select different values and observe how the model is performing. And in case of L1 regularization, the absolute sum of the weights of the model are added with the cross entropy loss, and it helps reducing the overfitting. So let's train the model again. So, and we also need to change this on. So this will be now train batch L1. So let's run it. Okay, now then we have to, I'm not sure how this error is appearing. We need to copy this part. So this will be 15. Setup model return. Let's just mention for L1 regularization. Okay, so in this particular case, we retrieved our model from GPU to CPU. So that's why we need to set up our model and send it to GPU again. Otherwise, there will be like a device mismatch. Two types of tensor, one is CUDA tensor, other is CPU tensor type of issue. So let's just set it up again and just copy and paste. So let's copy this one as well. So train the model with L1 regularization. So this will be 16. So again we copy this training block. The code for training block basically. So here we need to change just this part. Instead of train batch, now this will be L1, train batch L1. So now let's run it. Sorry, what happened? Okay, sorry, I have made mistakes. So there will be a bracket here, and this will be capital. So quite a few mistakes. This will also be capital. So this will be our new train batch, and we have named it train batch alone. So now I think it's okay. So let's run all these cells. Okay, so it's working. After the training is finished, I will explain the difference with the previous case. Okay, the training is finished. Now then copy this line. So this will be 17. Okay, also copy this code. Okay, now let's compare the difference with the previous case. So in this case, training loss is gradually decreasing, but after a time train loss starts to increase. This is overfitting. But in this case, both losses are gradually decreasing. I'm not sure why train loss is much higher than test loss. And if we compare the accuracy, so after 10 epochs, train accuracy 87%, test accuracy 85%. And in the previous case, train accuracy was 94% and test accuracy was 89%. Although it was higher, but the difference was larger between train accuracy and test accuracy. So we can say after using Elon regularization, the model is now able to generalize better. The same thing. Okay, let's also show the prediction. I'm not sure why this error is continuously coming. Not a problem for running the code. Okay, so let's 18. So model prediction with Elon regularization. So we can just copy, paste. So it also gives on wrong prediction from randomly selected 9 samples. If we run it repeatedly, we'll get different outputs. So now we get sandal, coat. If we run it again, we get dress, ankle boot, sneaker. So different outputs. Okay. Now, okay. Again, can again copy this line. So 18, now it will be 19. So define the train batch with L2. Now we have to use L2. Again, copy where. So copy this part, and we need to change it. So now instead of L1, we'll use L2 regularization. So this will be L2 norm. And in case of N2, we do not use the absolute sum of the weights. So use the square of the sum of the weights. So that's the only difference, and this will be L2. Then everything is the same. So that's the only difference. So let's run it, and we can repeat all the steps again. So 19, this will be 20, and this will be L2. So again just copy, and after that Control C, Control V, this will be L2. Then we have to copy this code, Control C, Control V, and instead of L1 now we have to use L2. Then I think train batch L2. Oh sorry, we forgot to change here. Silly mistake. Run again. It should work now. Yes, it's working. Okay, the training is finished. Now let's copy this part. Sorry, this will be 21. This will be 22. This will be L2. We have to copy this part. Okay, so you can see the train loss doesn't start increasing after a certain number of epochs. And if we compare, so train accuracy 91% after 10 epochs and 88 test accuracy. In case of L1 it was 87 and 85, so we got actually better results using L2 regularization compared to L1. And as I have already said, so when we do not use any regularization, our model overfits, and although the accuracy is higher, the test loss starts increasing. So it's better to have a little bit less accuracy, like in this case, but we want a model that is able to generalize better. So we can also see the difference is not as high than that we got in this case. So difference is around 5, and here it's around 3, I guess. So that's why our model performs better with L1 and L2 regularization, because it generalizes better and reduces overfitting. Now just one part is left. So now finally model prediction. So this will be L2 and 23. Again copy this code. Okay, if I run it, okay, so if I run it again and again, we'll get different results because it randomly selects 9 images from the test dataset. So for this particular 9 samples, we got t-shirt, and we have one round prediction. This is t-shirt but predicted as dress. So this is how we can train a CNN using LN and L2 regularization. And that's the end of this video. I will give the link for till this part. I have made another video only about CNN. I didn't use L2 regularization in that case. So if you want to see the code from scratch, then check out that video. Okay, that's the end of this video. Thanks for watching.